So hello and welcome to another podcast from the Engineering Department at Durham University. As always, my name is Chloe and today we're joined by Dr. Pete Matthews, who is an Associate Professor in the department. Welcome, Pete. How are you?
Good, thanks. How are you?
I'm very good, thank you. So today we're hoping to talk a bit about your role as Admissions Tutor for the department and about some of the taught postgraduate programmes offered at Durham, as well as a bit about your research and some of the things you enjoy doing in your free time. We're also going to answer some of the questions about postgraduate admissions sent in by our followers on social media. So thank you to everyone who sent those in. So to start with, can you tell us, Pete, a bit about your role as admissions tutor and what it involves?
Yeah, so as admissions tutor for the postgraduate taught program, which is just slightly different from the undergraduate program, what I'm really doing is I'm trying to get in good quality graduate students who want to extend what they've learned from their undergraduate times. A lot of our programs are based on extending engineering knowledge, so they don't work well for Durham students. Just want to say that at the outset. We do get some Durham students who do that. So instead of doing the MEng, they think that actually the setup of the MSc is slightly better, and they go from a B engine into an MSc. By and large, that's the exception. So really, the role is to try and get as many MSc students as possible into the department. Part of the reason for that is the funding they bring in. Bringing those students in has enabled the engineering department to expand by adding an extra 10 or so members of staff. So it is quite important. Not only are we providing great education, but it does also provide, sort of boost the department, if you like, by bringing the funds in to be able to expand with those extra people, extra academic staff. As far as what do I actually do in terms of that, how do I get those people in? Well, I set the bar. I set the expectations as to what these students need, and then I advise the university's central admissions department how to go about selecting people. And so the guidelines I give the admissions people is we do want to see people who are applying to Durham University have some clear engagement. One, with the subject matter, that the application material actually looks like they are really interested in engineering. And two, that they're also interested in Durham, that they just haven't copied and pasted their application from however many universities. So we are looking for that. So that's really what my role is primarily about.
Okay, and so for the students who choose to join us at Durham, what sorts of MSc and other postgraduate programs are offered?
So we currently have 4 running. So we've got a civil engineering MSc, advanced mechanical engineering, new and renewable energy, and electrical and electronics. So those are the ones that are currently running. And this year we look to be having around about 140 students joining us on those across those 4 programs. We are also developing a new master's with the business school, so it's going to be a 50-50% share in energy management systems. So there is a technical component. That is, understanding how the energy is being generated, how it's being consumed. But then there's also kind of the softer side of running an energy type business, which the business school will be looking after. And that one we are planning on setting up for October 2022. So get those applications in.
That's great. So for someone who's looking to apply to a postgrad course at Durham, do you have any advice on what they should look for in a programme and how they could go about deciding which course would suit them best?
Yes. Do think, what do you want to get out of it? What are your goals? And then look for courses that meet those goals. Now, a lot of these courses are, of course, going to be very similar. So if you, let's say, go and do an electrical engineering course, a lot of them are going to be talking about electrical machines, etc., etc. So you want to have something more that you're looking for. And so in the case of Durham, one of the things that we offer is we also offer a multidisciplinary design project, which is quite challenging and quite different. we're able to do this because of the type of department we are. Being a general engineering department, we've got an easy way of setting up these sort of projects where we're drawing in students from the different engineering disciplines to all work on a fairly real life type project, and this simulates what real design projects are like as well. And the other reason I think Durham is a particularly interesting place is, of course, all master's programs will have a dissertation. The way Durham does their dissertation is that we try and engage the students into academic staff current research interests. So we don't have banks of standard projects that we've been running for who knows how many years. We do get academic staff to come up with projects that are relevant to their to their current research. And a number of these projects do end up then getting published. So those are, what I would say as reasons for coming to Durham. Now, as an applicant, you want to look for these kind of, if you like, these second level offerings that different departments would be making. So it might be that you don't feel comfortable about that type of design project that we have at Durham, and then maybe Durham's not the place for you. I hope that's not the case. But though, in my view, those are the sort of things that you should be looking at. There is, of course, also the fact that doing a master's does take a year. You want to make sure you're happy with the place you're going at. Again, we're all biased here. We do quite like Durham. It's got that mix of city and kind of outsideness, green space. Again, if you want a more urban environment, again, Durham's maybe not the best place. So there's, my advice is not just the course, but think about, it's a year of your life. You want somewhere where you're going to be happy spending the year being. My view, and I suspect you're with me on this one, is that Durham's a great place to be. It's got that kind of laid backness, that openness to it, which of course is why I am keen on promoting Durham.
Yeah, no, Durham's a really lovely city. For anyone who hasn't visited, I'd highly recommend. So can you give us an idea of how the application process works for the postgrad courses?
That is actually relatively straightforward. There is an admissions portal. So from the homepage, you go to looking to study as a postgraduate student. There's an application portal. It has a series of boxes. The one that I've described being the most important one, the sort of free text entry. You need to supply evidence of the degrees and certificates that you have. Typically people, a scan of them will do. Those that are not in English do need to be translated. Chinese ones are particularly interesting. Now, some of them already have an English translation with them. That's fine. But if they don't, we will need a translation just so we know what courses you've done. So depending on which MSc you go, you'll see that some of the MSCs do have requirements that you've taken certain courses. So for example, new and renewable energy requires people to have either taken some electrical engineering or some thermal fluids courses. And we want to see evidence that you've done that. For those people not coming from English language countries, we also require a evidence that your English is sufficiently strong. Some people question that. Some people think, well, engineering is all about numbers and equations, and will the thing that you're going to build stand to the environment you're putting into? And that's all about numbers. The thing is, firstly, all the courses are delivered in English, so you need to be able to at least understand English. But the second thing is that all the assessment happens using written reports. And so your written skills are actually very important. And so while some people think that engineering is just about maths, it is largely about the maths, but it's more than that. It's also about explaining why the maths will give you a working product, and that needs to be done using everyday English. So that is why we effectively have that. Then there are also getting some references, again, academic references or references from employers. They're great. and there's guidance as to how you can get that in there. Those documents can be added, they don't all need to be added in one go. They can be added in as you go along. And so the main one is that you provide your statement, and once you've got that, documents can be added as time goes along.
Okay, and what do you look for in a postgraduate personal statement? How does it differ from an undergraduate personal statement?
So again, we are looking for clear engagement with the area that you're looking to study into. There is similarity between postgrad and undergraduate in that sense that you want to demonstrate that enthusiasm, you want to illustrate it one way or another. But of course, with the graduate one, you are taking that bigger step into real world problems, and you're expecting a little less dreamy talk, a more sort of grounded, I know I can do this, rather than I'd love to do this because I've taken kit to pieces for so many years. Now you're sort of saying, well, okay, there's this additional bit of reality. Is I've looked at the problem, I've already studied the problem at undergraduate level. This is what I think the problem is, and by going to this course, I will be able to solve it because I will be gaining these particular skills and these particular bits of knowledge in this particular course. And you put that in there, and you're in. There is a course, we read it, and we apply a filter, and we sort of effectively assess how realistic that is. But that will see you get very well through the system. If you can identify real problems and demonstrate that you understand how this particular master's is going to help you solve those real problems, and how these particular courses that you're going to be doing are going to improve your life, or improve your environment, your country, back for international students, that's great. That's really handy. The other one that's very good to have in there is why Durham, and again, that helps because it shows that you're putting the effort into coming to Durham, rather than you just having a blanket bombardment of various universities that you're trying to apply to, and it looks quite generic. And the application form to Durham could equally well go to Newcastle and still make sense. So we want to sort of see something that says this application is really for Durham. I couldn't copy this and send it to somewhere else because it just wouldn't work.
There's some really useful tips there. Thank you. So we touched on it a little bit earlier, but can you tell us a bit more about the MSc Research and Development project and what this involves?
Yes. So this is worth half of the MSc. It is the biggest part of the MSc, and I always think this is the most exciting part of the MSc. It starts off before you arrive, and that is with us academics looking at what kind of research we're doing now. Quite often we think, do you know what, I've got a bit of a problem here that I don't know how to solve this one, and we use that as a basis for forming these projects. The other one is that I've done in the past is I've had a couple of times where I've thought, I wonder if. Now I don't have the time to look at that myself. I'd really like the answer. And so I write that up as a project, and it's a one paragraph summary of what I think the problem is and what sort of resources we have, and maybe how you might go about solving it. Round about December time, so once the students have arrived, these projects are made available, and students choose 3 or 4 that they'd like to do. They might contact the various supervisors to get a bit more information, and that's fine. And then those are ranked, and people, we then allocate students to projects. By and large, most people are happy because there are enough projects that the spread is sufficiently good. Some people don't get their first project; they usually get their second choice. Very rare that it goes down to a third choice, but it does happen. From then on, there's an initial meeting with the supervisor and the student, and at that point the project transfers from the supervisor to the student. It no longer is the supervisor's owned project, it's the students. And the supervisor's role at this point becomes more of a guide to the project. How do we think this project could form a good, strong project that's going to result in good marks? But it's key to understand that it is then the students' own project, and they can take it in whatever way they want to, under the direction of the supervisor. The supervisor might say, I really don't think that's a good way of going about this project, but the student can say, no, I'm confident this is the right way. That's a risk, but it's up to the student to decide. Typically, supervisor and student will meet once a week for about half an hour to discuss progress and provide advice. There's a bit of a break at around about May, June time for exams. So at that point, the students will really focus on their exams. We, academic staff, we take a seat back and just take the pressure off. After exams, the students then go into 100% project mode, and they basically work full-time on these projects right the way up until mid-August, when the dissertation project gets submitted. The format of that dissertation is a 10-page report. It's a fairly dense format. It's 10-point, so it works out usually as about 3,500, 4,000 words. So while pages, it doesn't sound that much, but in terms of words, it is. And students typically would have more than 10 pages to say, and so that's one of the challenges as to what do you put in and what do you leave out. Because with a 10-page report, it's got to be very, very hard-hitting, and you do also have the ability to be really impressive and really surprise the examiners. Once that's submitted, it's examined by the supervisor and another member of staff, and we examine it orally. So both will read the dissertation. The second member of staff will discuss that project with the student for about 20 minutes, and then the supervisor gets another 5 minutes to ask any additional questions. And based on that, so based on the reports and the discussion that the student and the staff have, a mark is arrived at. Students tend to do very well in this because it's exciting, and because it's quite often the member of staff's own research interest, there is an enthusiasm, and that enthusiasm tends to rub off onto the student. And so we do find that on average, the dissertation marks are higher than the exam marks, because people put in that little bit more effort into making sure it's a really excellent piece of work. And occasionally some of these pieces of work then get published. And that's always very satisfying, and indeed it's an extra CV point for the student, that they then have a journal publication to their name.
Yeah, that sounds really exciting. So for those who are listening who may not have met Pete, as well as being admissions tutor, he's also a lecturer in the department. And last year he actually taught me part of engineering mathematics, which is a second year module. So can you tell us, Pete, a bit about the modules you teach?
Yeah, so there's one that you've just described. I teach the second year probability and statistics. Engineering is getting much more about looking at reliability, and reliability involves looking at when things fail. We don't know when things have failed, because if we knew how things would fail, we could design it out from the outset. So you're looking at the uncertainty as to why these things fail, and that's why probability and statistics is such a natural way of doing it. That's why it's such an important thing for students to understand and work with. And so that's why we have that as part of the second year course. In addition to that, I also teach one of the first year computing courses. It's the free elective, so not all engineers take it. It is offered to other science departments, and it's on computational tools for engineers and scientists. And this is not a programming module. This one is all about using existing tools to solve engineering or science type problems. there is a little bit of coding that is involved, but I make a big thing about saying, I don't want to see the code. I don't care how bad that code is. So long as you've been able to do the science and use the tool and use the code to drive the tool to get the science that you want to do, you're good. And so it's much more about using these tools to address engineering and scientific problems effectively, encode them into the tool, get the tool to do its thing, and then extract the results and present those results in a report. So really it is about using tools that are available and merging those with the work that you want to do. And quite often the work that you want to do is not necessarily the work that the tool had initially envisioned. So sometimes there's a little bit of taking that tool and getting it to do something a little different. A little bit like using a butter knife to unscrew a screw. It's not really meant to do it, but you can do it, and it gets the job done. So those are the main two courses I provide. I've provided others in the past, but they come and go.
Yeah, I know a lot of people who took that module in first year actually, and for anyone listening who's choosing their free elective, I believe it's quite useful for engineering, so definitely worth bearing in mind. So I've also had a look at some of your research, and there's quite a variety of projects you've been involved in from what I can see, from working wind turbine diagnostics to looking at design analysis, which I believe was a project in partnership with Rolls-Royce and BAE Systems. So what's been your favourite projects to work on in terms of research, and is there anything you're working on at the moment?
Yeah, so just going through the history of my life, my biography, which you've summed up in pretty much 2 sentences. The original design work that I was looking at was basically doing data mining, but with very small data sets. The thing is, I didn't know it at the time, and I thought I was a design engineer. But when I came to Durham doesn't do a lot of design research, and I got into the energy group, where they have a lot more data. And particularly wind turbines. It was just as wind turbines or wind energy was starting to take off. And as you know, wind turbines have a number of sensors on them, typically a couple of hundred sensors, looking at a variety of subsystems. And the turbine operators were starting to think, well, maybe there's something in this data that we could actually use to improve the operations of these machines. And so that is how I got into it. And so as far as my favorite project goes, I would actually say it was my first project within wind energy. So it was kind of my introduction to the data that is available on these machines. And what we were looking at there was we were looking at the pitch motors in wind turbines. Now, for those who don't know much about wind turbines, allow me to have a moment here. If you look at a wind turbine, it's got these 3 blades on it, and those blades can turn. Depending on how much wind there is and how much wind you want to catch, you turn that blade from being effectively flat on, sort of very high lift blade, to where it's practically perpendicular to where it's a very low lift blade. And it's got a motor to do that. It needs a motor to do that. And these motors fail. And at the time, these failures, or a lot of failures in wind turbine systems, were just unknown. It was, but it's gone broke. And it didn't really matter that much either, because there weren't many wind turbines and they were all on land. So if something went wrong with your turbine, you hopped on into the Land Rover, you drove up to the turbine with a tool bag, you climbed up it. They weren't very big, so you weren't out of breath by the time you got to the top of it, and you fixed it. People started, they were starting to get bigger and more expensive, and therefore we wanted to keep their uptime going for a bit longer. And so we were looking at this particular problem, and the PhD student involved had found something. And the bit I'm particularly pleased of is how we were able to show that we were actually identifying faults 2 weeks before the turbine actually broke. And so there was a particular graph that I was quite pleased with, that I helped the PhD student find this one out, because that really set this area on fire. Because you could certainly say and argue, saying, look, if we see this particular signal happening in the data, get that Land Rover ready to go. Now, once those wind turbines move offshore, you're not just talking about hopping into your Land Rover. You are talking about making sure that the weather is looking good enough to be able to hop out onto your boat, and make sure that the weather is going to be good enough when you get to the wind farm that you can hop from the boat onto the wind turbine. Because if it's too wavy, you're not getting off that boat and onto the wind turbine. And so that's really when we start saying, well, okay, if we can give you 2 weeks worth of notice that something is going to happen with the wind turbine, you can actually start planning that in a meaningful way when visiting the site. And so for that reason, I would put that as my top project.
That sounds really fascinating, really interesting. So what led you to join the engineering department at Durham?
Well, that goes back to the design story. I came to the end of my PhD, and I was doing a postdoc, but you're only going to be doing a postdoc for so long, because you're constantly kind of having to extend your contract. And it was getting to the point where I was getting my contract extended every month, and it's not a great place to be in. So you start looking for more permanent type jobs. And Durham at the time was looking to add some design expertise into the department, and they basically advertised my PhD as a lectureship. So I applied for it, and I got it. The design component, you're going to say, well, hang on a sec, well, where is design in Durham? Well, that never really took off, and I then moved into wind energy. I still have a background in design, and I'm still interested in it, and I help out with design projects wherever I can. But I'm well aware that my design expertise is a little rusty. It stopped at about 10 years ago. So I am wary of claiming that I'm an engineering design researcher. I'd say my background was in engineering design, but I can help people. I can teach it, but I can no longer really do it.
Oh, so finally, when you're not working in the department, what is it that you enjoy doing in your free time?
Well, as an undergraduate, I used to row quite a bit. And possibly is one of the reasons I carried on to do a PhD, just so I could carry on rowing at college. And I carried on. So I still do go out, and I still do enjoy hopping into a boat. I'm not quite as fast as I used to be, but I still quite like going out. I find it quite relaxing to be out on the water and just watching the world go by, even if it does go by a bit more slowly now than it used to.
Yeah, it's very peaceful by the river in Durham. Highly recommend it for walks as well. It's sort of taking study breaks. So thank you so much for joining us, Pete. It's been great to hear from you. And thank you to everyone who's been listening. We hope you've enjoyed this podcast. Be sure to keep an eye on our social media pages for future episodes and for more news about our department.
Great. Thanks a lot.